Hi, welcome, and thank you for joining us at Crossroads. Just like every month, we are here thinking about what intelligence is and what parts of science can help answer our questions about its mechanisms and mathematics. Crossroads is put on by Cross Labs, which is a research institute in Kyoto and Tokyo aimed at understanding the mind through computational research. We explore ideas about brain science, information sciences, artificial intelligence, artificial life, and how they can enable new technology and changes in society. The cross in Crossroads means we're very interdisciplinary, and this is our monthly fun public forum based on the sciences of the mind and intelligence. We're supported by Cross Compass, which is a leading AI company in Japan, which leads the industries in manufacturing and other technologies. Before we start, I wanted to give a shout out to and special thanks to Olaf Witkowski, Antoine Pasquale, Stephen Wei, Oneris, and Katsu-san. And today what we're going to be doing is we're going to have three parts of this talk. First, we're going to have our guest speaker giving a talk. The second part will be a Q&A session, which is hosted publicly on YouTube. And the third will be an off-stream discussion hosted on Zoom, and we'll share that link later. So today it is my pleasure to introduce Claus Aranha, who is an assistant professor at the University of Tsukuba. And the topic today will be AIWolf, Can Game AI Stop Being Sus? All right, Claus.
Hello, Lisa. Thanks for having me. And hello, everyone. Oh, all right. So yeah, let's get started. So like Lisa introduced, so we're talking today about AIWolf Project, which is our little effort to try to make game AI stop being sus. So before we begin, just a quick word. So what do you need to know about me? Like, who is this guy talking to you right now? So as I work at the University of Tsukuba, where I research evolutionary computation, artificial life, and other ways to make computers do cool stuff. I'm actually from Brazil. And what we're talking about today is the Werewolf game and why people doing game AI should be paying more attention to this game. So let's start. What is the Werewolf game? It's a quiet night. You live in a small, sleepy village until the werewolves arrived. During the day, they look just like you and me, but every night, someone disappears in a pool of blood. Fear, uncertain, doped, the villagers don't know what to do, so they turn to the true and tested method of killing one person every day by democratic election. That's how they're going to expel all the werewolves from the village. Can the village be saved? So that's the story of Werewolf, which is also called Mafia in some places. And it's a party game that models a conflict between an informed minority, which is the group of werewolves, and an uninformed majority, which is the village. So it's usually a game between 5 and 20 players, although there are like super giant games with 30 or more people. These games were first played at parties, so that's such a party game, but more recently you can play them on internet forums, you can play on chat rooms, and we're going to talk a little bit about that later. But in the beginning, each player receives a secret, either a werewolf or a villager. The werewolves know each other, the villagers don't, and this difference is the main tension in the game. The game progresses in two phases, day and night. The day phase, all the players discuss and vote one player to be eliminated from the game. The night phase, the werewolves choose one of the townsfolk to automatically kill. And this repeats. Day phase, people decide, oh, maybe A is a werewolf, maybe B is a werewolf. Night phase, werewolves kill someone else. This continues until either A, the villagers eliminate all the werewolves by voting, or B, the werewolves eliminate enough villagers so that they are not a minority anymore and they can form a voting block to eliminate all the other villages. Then the game just stops there. Just to give like a quick demonstration. So imagine like we have a game with 10 people. Out of these 10 people, in the beginning, 2 are selected to be the werewolves. So this is the secret that they possess. They know that each other are werewolves. The other villagers don't know who the werewolves are. And then we have the discussion. So people just talk, oh, I'm a villager. Oh, I don't think that you are a villager. I think you are lying. No, I don't think that you are lying. And you're sus, right? So after they discuss, they decide who is the person most likely to be a werewolf. And they vote to remove that person. Okay, so that person is executed, removed from the game. They cannot participate in the game anymore. They cannot talk anymore. They cannot vote anymore. Then we go to the night phase. In the night phase, the werewolves choose someone to attack. So, okay, this guy led the discussion last night, so we're going to remove them from the game. Finally, this is just a very, very basic description of the game, but there are many, many variants. It's an old game, and there are different ways to play. One that is most common is to add special powers. So some of the people in the group can have some sort of special power that they can use. For example, one of the players can be a seer or a cop, and they have the option every day to choose one person and check without error if that person is a wolf or not a wolf. And that kind of information role can help the city find wolves earlier. And there are many others, like protectors that prevent the kill. In the case of werewolves, roles that block, or people that vote without showing who they voted for. There are many variants in the game. Why is this a fun game? Okay. This was a game that actually exploded a lot in popularity in the 2000s. In Japan, in 2010, there was a big boom in werewolf popularity. One thing about the game is that as a party game, it's very open for role play and socializing. So, like I said, in some places this game is known as Werewolf, in some places it's known as Mafia. Some people put other, like, other clothes on the game. So here, for instance, was when I was playing a game in a forum where it was a Dwarf Fortress themed werewolf game. And also, like, the game lends up to very lengthy discussions, like pages and pages of people discussing, no, you are a werewolf because of A, B, C. No, you are a werewolf because C, D, E. And then you have this huge wall of texts of people going back and forth. So for people who like role-playing, or for people who like discussion, or like people who like using the social capital to try to guide other people, and these are also things that are attractive about the game. If you are familiar, if this feels familiar somehow, more recently, the game spread into other directions in what is usually called social deduction games. There are several games that follow the same idea, a genre of games where a large part of the gameplay involves finding information by talking and observing other players. So we have some that goes a little bit more towards structured gameplay, like Werewolf is very unstructured. You have the discussion and you have the votes, but other than that, it's very freeform. We have, for instance, Bang is an older board game. It's a card game where people can shoot each other, can defend itself, but it has a secret that some people are bandits, some people are not bandits, and part of the game is doing the deduction to see who is a bandit and who is not. More recently, we had Secret Hitler, which is also another board game where all the players, they are part of like a group that has to decide rules for a society to make it more open or more closed. And one of the players in the game is secretly Hitler, and they want to turn the entire society into a fascist state. So they want to try to pass the right laws so they can take over the society. So it's interesting, especially Secret Hitler is interesting because the laws that help you make it easier to find Hitler are also the laws that make it easier for Hitler to win the game. So that's a very interesting push in social deduction games. More recently, we had like the very big boom in Among Us, which follows more closely the Mafia idea of, okay, there are some imposters here and we have to eliminate them before they eliminate everyone. But it has a twist that you have like the part of action game. You have people running around and completing tasks. So, and there are many, many other games in these social deduction games. I'm going to focus the talk today on Werewolf, but you can imagine that what I'm talking about here kind of applies to all sorts of social deduction games, really. So, why is Werewolf a good AI challenge? Okay, I think most of you hearing know by now that game AI and games, they go hand in hand together, right? Games are a great playground to train and test new AI algorithms, not only for playing games, but for making games, for analyzing players, for generating new programs. And there is a very, very long tradition in AI circles to first train something on games before applying to anything else. A long time ago, it was like, okay, if AI could beat humans in chess, then AI would be as smart as humans. And although, I mean, it did not quite turn out that way, but there is a thing that whenever humans put a hand on something, they make a game out of it. They make a game out of dances. They can make a games of auto computer. They make games out of looking things in the distance. So if we can make computers play game, I think it helps a lot to move computers toward being closer to humans. And we have a lot in in media, computers playing games as part of, okay, this computer is intelligent. They can play a game with a human. If we look at recent efforts of humans, of AI researchers trying to make computers play games, well, we have, like I said before, the long quest for making AI beat humans in chess, so that we got Deep Blue beating Garry Kasparov in 1997, almost 30 years ago. Wow. And then we have the same year we had here in Japan, we had people working on Reversi. So we had Logistello beating Takeshi Murakami in Reversi. And then in 2004, we had Skynet beating humankind in war. After we got that back, we got in more 2015, we're trying new games. So we have Texas Hold'em, which is secret information. It has bluffing. It has a lot of probabilistic, different from chess, but they managed to solve two-player limited, and there are very, very good poker playing AIs out there nowadays. And more recently, we got Go, which was this huge challenge because it was enormous search space. But we managed to make AlphaGo that beats the Go champion. So where does AI go from there? Well, it has been already 5 years since AI beat Lucido in Go, and there are many other games that we are making AI play, and we are now not only making AI play games, but we are also making AI build games, AI test games, etc. And different games, they have different characteristics. In the beginning, we focused a lot on games with complete information and slowly going towards incomplete information, like in poker. A lot of the time, we're still playing a lot of symbolic games, such as chess and Go, and even poker. It's mostly about playing the rules of the games. But we're also spreading. People are researching games such as RPGs, games such as Hanabi, which is more about trying to coordinate moves with other players. And in that context, I see Werewolf and social deduction games in general as a new and very important frontier for game playing AI. Okay, because not only is it an incomplete information game, it has this incomplete, uneven information contest, but also because it's a communication game. So how would we characterize the Werewolf game? So Werewolf game is incomplete information. At the very least, people don't know the setup of the game. But not only that, as the game is very freeform, a lot of important things in the game is the beliefs of other players. Each player does not know what the other players believe, how the other players face the game, what the players think about each other. Then we have also the linguistic components. In Werewolf, the players have to encourage each other. They have to question each other. They have to lie to each other. Then we have the analog aspect. Anyone can talk at any time. I can interrupt you. You can interrupt me. And then we stop to vote for the players. So there's not turn taking, which make the game a little bit more difficult to play. There's the multiplayer aspect, right? That we have different players. You can have different numbers of sides. And we have both the cooperative and no cooperative. It's no cooperative because one side wins and another side loses. But at the same time, the villagers, they need to cooperate if they want to find the scum, the werewolves. And the wolves also need to cooperate, not only between themselves, but they need to cooperate with the villagers because they are in the minority. The wolves will not be able to win if they do not manage to bring some of the villagers to their side. So this sort of persuasion is something that is very different between Werewolf and other games that AIs are playing today. So let's go a little bit deeper into these characteristics that make Werewolf an interesting game for AI. So, okay, why is Werewolf difficult for AI? So incompleteness of information. So there is an asymmetry in information, like I said before. Coordination of players, which I also mentioned. Speculation. So speculation is something that AI needs to learn to be able to play AI Wolf. It needs, of course, natural language processing to be able to do discussion, persuasion, how can an AI persuade a human to do something, and also like all the parts of virtual agents. So there's a lot of body language, synthesis of speech, nuances that you have to transmit, etc. So there are many, many different fields. You can approach the challenge of making an AI play werewolf from many different sides. There's a space, there's food enough for lots of different researchers to work on this challenge. Let's focus on some interesting challenges. For example, one thing that is key in werewolf is trying to figure out what the other people are thinking. For instance, let's say that you watch two people talking. One person says, "Oh, I know that you are a wolf." Another person says, "No, I am a human." Now, what's going on? You are a third person looking in. Maybe the first person who is talking is a wolf and they are accusing a human, trying to get the human lynched. Or maybe the first person is a human and the second person is a wolf, and you're trying to understand if they are arguing from an honest point of view. Or maybe it's two humans arguing against each other and you need to figure out. So you can say, hey, maybe both of you are wrong. Or maybe it's like a wolf pretending to be a human, trying to confuse you. They know that you think they are a wolf, so they make you think that if you think that. So you start to get into these recursive words. Oh, a person A is saying that because if they were a wolf, they would not say that. But if they were a human, they would know that a wolf would not say that, and they would not say that. And you can get into these recursive ideas, these representations, which is like something quite difficult if you look from the point of knowledge representation. There are a lot of people working with like knowledge representation, knowledge models to try to represent knowledge in a werewolf game. And that's a very interesting problem. Then you have the key idea of like, how can you make an AI lie, right? I mean, of course, you can just make, okay, this is the information is true, and the AI will say the information that is the opposite of true. So the AI is lying. But it's not so simple, right? Like the AI needs to know what the other agent believes to be able to construct a narrative that would fit that agent's worldview as a lie. So lying is actually a problem that is really interesting. And also, to lie, the AI also needs a consistent worldview. So because you cannot say, can say one thing at one time and then I say another thing later. So that becomes inconsistent. And not only lie, also AI needs to detect the lie. So if another player is lying, the AI needs to be able to construct the word model to see if what the other player said is consistent with what they seem to believe. Okay, so this sort of argumentation is actually something a very interesting problem. It, of course, applies not only for werewolves, but any sort of negotiation that computers might need to do to each other and with humans or assisting humans in the future. So that's another interesting problem that we see in the werewolf game. And then we have the interaction part between agent and humans, because one of the goals, just like in the RoboCop project, you have the goal of having a team of robots playing against a team of humans in soccer. In the AIWolf project, the idea is to have like a robots playing against humans in werewolf. And what do you need to do to get there? I mean, in the beginning, of course, you need to do image recognition and speech recognition so the AI can understand what the human is doing. And of course, they need to process what the human is saying to transform that into changes in the world. And then they need the conception to find out what are the word states for each of the players, like I discussed before. After they decide, they make the decisions, they also need to do like dialogue generation to decide what they're going to say to convince other people, and then emotion generation to be able to be convincing other players. Like anyone who already played Among Us or Werewolf or any other sort of social deduction game, it's not only about whether you are right or not. It's not only if you have a good or bad argument, but it's also if you are able to reach the other person, if you are able to emphasize with other person to convince them to go around with whatever you're telling them, even if you're a wolf or if you are a human. So there are all these different layers of interfaces between humans and computers that are important. It's not only like pressing, right-click A to attack with all your zerglings in the opponent base. it's a little bit more involved to have the interaction between players in the werewolf. So, as you see, there's a lot of different approaches, a lot of different problems that need still to be solved for the AI to be able to play the werewolf game. And to try to solve these problems, we have made the AIWolf Project. So what is the AIWolf Project? The AIWolf Project is a long-term project involving many researchers in different universities to create AI agents that can play the werewolf game. And so like I explained in the previous section, this project requires different approaches from other game AI agents. So we have people that are doing machine learning in this project. We have people that are doing human-computer interfaces, people who are doing natural language processing, people who are doing coordination, negotiation, etc. These are some of the members of the AIWolf project. These are just a few of the members more too, but the project has many other more members that I want to acknowledge for the participation and the collaboration of the project. And so what have we been doing recently, right? So one of the key things that the project has developed was the AIWolf Protocol, which is a formal language that can be used so that people like from AI background or knowledge modeling background can generate some AIWolf agents that play werewolf without necessarily need to go through the natural language process party. So this protocol was initially composed. We analyzed game logs from Japanese werewolf BBS. So like I said, there was like a huge explosion of werewolf in Japan around 2010 to 2015, lots of BBSs. So we could contact the organizers of the BBSs and we got some of the logs that they had. And by analyzing these logs, we made a list of the project make a list of the most frequent utterances, and using these most frequent utterances, the project made the AIWolf protocol that could be used for agents to talk to each other. Currently, we are on the version 3.6. The protocol has possibilities for logical argumentation, accusing people of being wolves, making temporal relations. So it's you can have some very, very interesting games using this protocol for the agents to communicate. Another big thing that we have been promoting is the AIWolf server. So the AIWolf server is a framework that allows you to concentrate only on building the agent that plays werewolf. So it's a server made in Java. It has an API for Java agents that they can connect directly to the server, and it also has like a layer for connection through TCP/IP sockets that for agents to exchange information. And we also have like example agents in Python, Java, and C#. So people can C#, so people can program an AIWolf agent in their favorite language and talk to the server, and then hold many different players playing on the server. The server can be configured to have different setups, different number of power rows, different number of days, etc. So it's really interesting. It also support both game through the protocol and also game through natural language processing. We also have visualizers to put the game into like a small virtual table for people to play. And more interestingly, and something that I want to talk a little bit more, is the AIWolf competitions. So we have held 7 AIWolf competition so far. It's an open competition for programmers, not only for researchers and academics, but we also have a very large number of like people who do AIWolf programming on the side as a hobby, and they have some very good results in the competitions, and we're very happy for having people from non-academic background participating as well, people from the industry. The first competition was in 2015, and from 2015 until 2018, the competition was held at SEDEC. From 2019, we started to open the competition internationally by translating all the materials of the competition to English, and we held in 2019, 2020, and 2021 in each KAI. And I'm going to talk a little bit more about these 3 editions. So, the question, can AI play werewolf? Okay, so we have 7 competitions, and what were the results so far? So, the competitions are actually quite popular. We have around 40 competitors participating in each of the recent contests, so we're very happy for that. We would be happy to have many, many more people. The best agents so far, the agents that won the competitions, usually they use some sort of machine learning model to estimate the likelihood of other agents being the werewolf. So this is the meta right now of the AIWolf contest. You get a very good machine learning model behind your agent. The machine learning model tells you who is most likely to be a werewolf, and you vote that guy. Most agents, however, use rules of thumb, so scripts to determine actions based on the werewolf estimation. So they give werewolf scores to each player, and then they decide how to play by that using like a hard script. So what kind of machine learning models do we see among the AIWolf competitors? Okay. It's interesting to see that one of the key questions is like, how do you define the inputs of the models? So some people do like by attributes. So they have like voting records. They register the voting record of each player and use that as one input. And then the number of times they talk, the length of the talk, if they claimed wolf, if they claimed some sort of power role, which if they talk to everyone or if they talk to someone else. So they do a lot of like data extraction, they attribute extraction from these meta values from the game. And they use that as the input for the neural network. A different approach was using like recurrent networks and LSTMs, and they directly tokenize the discussion. This is for the protocol division. So it's like they tokenize the regular AIWolf protocol discussion, and they use that as the input for LSTM and output like a probability of one player being AIWolf. Some people did an interesting approach was not trying to evaluate the probability of one person at a time, but the probability of pairs at a time. So in the current AIWolf contest, the design of the game is fixed. It's always 2 werewolves, 1 seer, 1 bodyguard, and 15 players. So instead of trying to estimate one person, they try to estimate pairs. This multiplies the number of the outputs, but it helps the ML model to try to find the relationships between the players. Another problem, though, is like, how do you define the learning data? Because you don't know what are the other agents going to be. If you, of course, now that we have like 7 years of contests, people get agents from previous contests and use those to train their machine learning models. But at the same time, this allows people also to try to do like adversarial options. So we have had competitors in the last 2 events that they created agents that try to explicitly act very different from other agents in previous competitions to different degrees of success. Then we have a lot of other interesting strategies. People like to try many different things, and it's really interesting to see all the sorts of strategies that are used to create AIWolf agents. So first, we have people that do strict scripts, so deterministic scripts like voting for agents with the highest winning rate because they have a history of recent games. So they know which agents have won more lately, and they can vote more for them to try to eliminate from them from the game, or maybe voting agents for agents with lowest winning rate. In the idea that you are probably, statistically, you are very likely to be in the same team as the best agent because there are more villagers than non-villagers. And if you eliminate the bad players, you are more likely to win. There was one approach that I personally very liked. It was one person that got the open code from 5 agents that won the previous competitions and used a multi-armed bandit. So like we have like sessions of hundreds of games, and every game they try a different agent from the past. And if that agent wins, they give a higher probability of try that agent again in the future. If an agent loses, they give a lower probability to try that agent again in the future. I found that to be quite a cute approach for AIWolf for the agent. Also, we had another funny one is that we made, to facilitate people to participate, we created a website where you could build your own AIWolf agents. So we had like a base AIWolf agent, and with changing some options, you could create your own agent on there. And someone did like an optimization on top of that. I found that to be quite interesting. But if we talk about it, what's going on right now is that we're kind of in a local optima in the competition. The neural networks estimators, they perform really, really well. But when you open the games to see what the agents are actually doing, the games kind of look like this. It's two robots, and robot one is saying, I think you are a werewolf, and robot two is saying, I think you are a werewolf. And they just repeat to each other. There's not really a lot of interaction between the agents. And another thing that we are observing, and this is we observed this on this last contest, this trend. So in 2019, the winning agent got 0.68 winning rate as town and 41% winning rate as a werewolf. In 2020, the winning agent got 74% winning rate as town and 37% winning rate as werewolf. And in this year, the winning agent had 80% winning as town and 19% winning as werewolf. So what's going on here? I mean, my personal interpretation of this is that the agents are really getting really, really good at detecting the werewolves, but they are not good at being werewolves themselves. So there's this imbalance here that is kind of that may explain the local optima that we're seeing in werewolf competitions. We also have NLP Division. The NLP Division right now is still very small. We have about 5 to 6 participants each year with human judges that evaluate the outputs. It's really, really interesting. They cannot hold a very long conversation, but it's a very interesting division. And I really would like to see more people trying to make AIWolf agents that play using natural language. Okay, so we look at all of this, and what is the future of werewolf, AI werewolf, from my experience in the AIWolf project? Especially from the last 3 years observing, we started to ask ourselves, like, do we really want to win werewolf games? Is really winning the game the goal of a good werewolf AI? And if people who played a lot of social deduction games, they know that, for instance, social capital is actually a very big currency in werewolf and other social deduction games. What I mean is that it doesn't matter if you are actually a very, very good player, what is actually skill in a social deduction game? You can be a very good deductor, but if you cannot talk to the other players, you can get that situation where you have like a public lobby in Among Us that you say A and everyone vote for you immediately, and you can be the best Among Us player in the world. You're going to die and you're going to lose the game. So your relationship with the other players, playing the other agents is as important as playing the game itself. And right now the agents are playing the game and not the other agents. So that's something that we need to change in the future. And also maybe focus back on the idea of playing against humans, like making agents that are fun to play and are enjoyable to play. So we're kind of in a changing point in the directions of the AIWolf project, and it would be really, really nice to have more voices and more people participating. So I would really like to invite everyone to participate in the next contest next year, and also to help us make more agents. We have lots of codes for people to. It's really easy to make an agent, so I would really like to see more people participate with us. All right, that brings me to the end of my talk. A little bit over time, but I hope you forgive me. And there's a bunch of links here for you to learn more about playing werewolf and making AI for werewolf. We have the webpage of the AIWolf project. We have a GitHub where we have the samples for C# agents, Python agents, Java agents. That generator I mentioned before, it's here, so you can use this generator to automatically generating an AIWolf agent in Java by setting some parameters. And the QR code here is a AIWolf tutorial that I did for COG last year, where I go into more details about how you program an AIWolf agent in Python. All right, thank you very much, and thank you Cross Labs for inviting me to talk about werewolf today.
Great, thank you so much. So now we will take some questions on Slido, and I'm sorry, it looks like my graphic is frozen, so just pretend that I'm looking really animated right now, and I'm really excited about your talk, because this has been really great. Sorry about that. But we'll go ahead and switch over to Slido. So the link is posted in the YouTube chat, so go ahead and check that out. I had a question. So just from your experience as somebody who is, I guess, looking at these entries in the competition, do you find that the strategies that people submit, like these AI strategies, are they similar to the strategies that a human would use to play werewolf, or are they different?
That's a very, very good question. I mean, the how do you say, the benefit, the good way of saying that, if I were going to say, if I was going to be like gracious about it, I would say that these strategies are very much like maybe noob strategies. Well, I mean, I might be a little bit like too strict here, because it's actually really hard to make an agent that plays using strategies. There are a lot of humans that discuss what is actually the correct strategies. I mean, I used to be part of a werewolf mafia forum when I was in my PhD, and we had these huge discussions about what was the right way to play werewolf. But the agents that play scripts, they usually follow like the rules of thumbs that you see on Japanese BBSs for playing AIWolf, for playing werewolf. So they try to, like, if they are if they are a cop, they claim immediately, and then other people will counterclaim immediately. So that's something that you see a lot in BBSs. In the last day, if you have like one werewolf and two humans, everyone starts to pretend that they were werewolf to confuse each other, which is called like the power plays. But other than that, like the agents that are actually winning, I don't think that they play very human-like, to be honest. Like I mentioned in the talk, the agents that are actually winning the contest right now, they do an analysis of the agents that played before, and they try to estimate which one is the werewolf. And they have actually a pretty good hit rate. The problem is they have a very good hit rate because a very large number of participants, they start from the agents that won the previous year. So you have a little bit of a positive feedback loop here, right? So you have agents that participate in the previous year, and you can train on those agents to know if they are wolves or if they are humans. And then you have a very good chance of detecting if they are wolves. And that means that you have a good chance of winning. So, so yeah, I'd say that they are not really playing human. If you go to the natural language processing division, I think it's the discussions can be a little bit more human-like. I mean, because the natural language division, it's not only like how many games you win, but also like the votes of the judges. The people making the agents for the natural language processing division, they are trying to do things like, if the agent says hi, you also say hi, and if they make a joke, you try to reply to that joke and be a little bit funny. So if you're looking for more human-like, I would go to the results of the natural language processing division. The protocol division is very robotic right now.
Okay, cool. Let's go ahead and take a question over on Slido. So we have a question from Olaf, who is asking, how easy is it for AIs versus human players to make sense of the meta-analysis? Like, I think that she thinks whatever, like how key is social modeling?
Okay, so there are some papers on this. People are using modeling to like try to do knowledge modeling using some sort of like BDI models and like declarative models. I know that someone is a wolf, or I know that A believes that B is a wolf. But the problem with that is that that's a very like it starts to get more complex when you're trying to model what they believe other people believe. So, for instance, I believe that A is trustworthy, or I believe that B is mistaken. It's not quite there yet. It's relatively easy to use a model to believe that, okay, A believes that B is a wolf. So if A says that B is a human, then they are going against the belief and they are probably lying. So there's some results in that direction. But Not much more than that. And I noticed that actually Olaf is asking AI versus humans. I am not very familiar on the AI versus human literature. I know Professor Ozawa from Tsukuba has been doing a lot of studies on AI versus human plays. I have been looking mostly on AI versus AI plays, so I cannot really answer about AI versus human. About whole key social modeling, in AI, it has not been touched much yet. In humans, it's definitely essential. In humans, you play the person, you don't play the game.
Okay. So we have a couple of other questions.
Just before that, there's someone asking in the YouTube chat if the video is frozen. I think it's not only your video that might be frozen. I don't know.
Hopefully it's not frozen for everybody, but I guess if it is frozen for everybody, please just let us know in the chat and we'll see what we can do to resolve the issue, or we'll find out. In the meantime, assuming things are not frozen. Okay. So our next question is, how long does it take roughly to write a werewolf AI from scratch? So maybe this is a good question for people who are interested in programming something for the werewolf AI competition.
Right. So yeah, roughly, if you just want to write a quick script, like what I usually do when I get a new student that wants to do AIWolf, I tell them to write an "Oh my God, you suck" script. An "Oh my God, OMG US" is a script where it's a player that plays randomly until someone attacks them. If someone attacks them, they go ballistic against that person. I hate you. You attack me, I hate you. So that would be like a very trivial AI script to play. And you can do that in like an afternoon. You just need to, it's or even less. Like if you're already familiar with programming, you can do that like very, very, very quickly. To include ML, like I had a student that did like a short work on using ML to predict, and the student took like about, I'd say, 20 hours of work across 1 month. They were working about like 4 hours per week, and they did a pretty good agent that would not predict if someone else was a vote. They were trying to predict vote pattern. So it's pretty quick. I mean, you have all the scaffolding. You have like the callbacks on the agent. You just have to say, okay, what does your agent do when the server asks it to vote? What does your agent do when the server asks it to talk? So you just have to fill in the blanks in the code.
Cool. Well, hopefully we'll get some more entries for
I hope so. Yeah.
Next year, then, yeah.
I would be happy to help anyone that wants to go down that road.
Cool. Okay, so let's here's another question from Kai. So has anyone tried algorithms that have been developed or demonstrated on Hanabi?
That's a very good question. I am not super familiar with the literature on Hanabi. Maybe someone in the chat. I know that some people for the AIWolf project are looking on are watching us right now. So if anyone would like to add the answer in Google Chat, that would be really, really nice. But I'm not really super familiar. I think that like the collaboration necessary on Hanabi would be very useful for coordination in AIWolf as well. There's a lot of overlap between the two games.
Yeah, Hanabi's a really interesting game. I've only played it a couple times myself, but it's quite difficult in a good way. Okay, next question. We have two questions that are sort of similar, so we'll just do one than the other. So one question is, does someone try something other than machine learning for decision making? And then the related question is, talking about iterated prisoner's dilemma. So in the iterated prisoner's dilemma, tit for tat is a good strategy. An L for L bar problem. Some complex strategies sometimes evolves. Are there any simple strategies here? Like, so I guess the general question is like, what kind of strategies
Yeah.
are people using? Yeah.
So I think the two questions are actually they are very very interesting for different reasons. I will answer the first one very quick first. Like other than ML, there's a lot of people that tried to do things such as like just scoring points for the agent, something more similar to a very very simple Q learning or just rules of thumbs. Doing rule of thumb. In what I have seen of AI Wolf competition, people usually do either ML or scripts. I have seen papers of people doing knowledge modeling, but I have not seen that in the competition itself yet, which is kind of a pity. I think that would be quite cool. Talking about Takashi's question about iterative prisoner dilemma, that's very interesting. Going a little bit like going into werewolf theory. Okay, there are some people who have done analysis of the werewolf game, and in the analysis, usually you have if the setup is like this, random voting is more likely for the town to win, so you have a higher probability of being town and you just do random voting. Or if you have certain power roles, you have some strategies. There are strategies if you have this. The problem is real life, the game itself, like the interesting part of the game is when you play with humans, and then you have someone that when you start to describe how you should win using interactive prisoner's dilemma, the person will say, "You're sus," and they will vote for you and they'll shove you up and then you cut you and they will not let you say anything. And that's the part that I think it's really, really interesting. It's like, again, it's the social capital. It's how do you deal with other people? How if they tell you, "Oh, stop your lecturing, you're talking too much, you're probably a werewolf trying to appear to be too intelligent. I'm going to get you out of the game." And how do you deal with that situation? That's something that is really, really interesting. But if you're just looking at like game theory, if you look at this from a game theory point of view, it depends on the setup. There are some strategies.
Okay, great. Thank you. Okay, so next question, again from Olaf. So how about mixed games, humans plus AIs? Does Werewolf work well for it? As in, does it create new and interesting dynamics similarly to having like children and adults playing games at the same time?
So I have seen a few videos of humans and AIs playing werewolf together. And it's really interesting because the AI is not very good at explaining itself very well. So what happens is usually like the AI accuses the human, and the human has no idea why that's going on, and they get very surprised, maybe feel a little bit hurt about the AI accusing them, or laugh at it. So I think this is some sort of like, it's interesting to see like this interaction between an AI and a human playing a game which is about trust and about like this sort of discussion. I think it's very interesting to see like this sort of collaboration and maybe like appeal for emotion that could happen between an AI and a human in this sort of game.
Cool. Okay, so we have one more question. So if anybody else has a question, it's a last call. So go ahead and put that in Slido. So our last question, how do you score the agents? Does the agent still win if they're on the villager team, even if they die before the end? Does that affect the agent's cooperation?
Right. So yeah, there are two questions here. One is how the scoring is done in the werewolf game, and two is how the scoring is done in the competition. So in the werewolf game, the score is done by the team. So even if you die, if your team wins, you win. So that goes back to what I was saying about like iterated prisoner dilemma. You're playing for your team. And that's something that is very different about agents and humans playing, because robotic agents know that they win even if they die. So they don't care so much about dying. But when you play like a purely human against human playing, they really don't like dying. No one likes being voted out of the game. So humans will do whatever they can to not being voted out. But for the rules of the game, you are not you get the point even if you die. For the competition, for the AIWolf competition, what we do is that we rank agents based on the victory rate ratio so far. So, for instance, we actually make the agents play a huge amount of games. Like in the last competition, the play agents played, if I'm not mistaken, 400,000 games, and we calculate the victory ratio of these 400,000 games. We try to keep the agents playing the same amount of games among each others, and then we check if the differences are like what is the variance, to try to make the differences bigger than the variance to score the agents that way. We have been thinking about changing that. Well, maybe not changing that, but adding more scores, like adding a survival score, even if that's not for the rules, but maybe that would make the agents play a little bit more human-like. Or adding like a score about the agents trying to predict the outcome of the game at different points. So we're trying to think of new ways to evaluate the game so that the agents are playing more interesting ways.
Okay. Cool. And then we have one more question. So in your opinion, what is the most difficult part in Werewolf AI? Uncertainty or communication or communication/collaboration, and why?
It is definitely, it's definitely communication and collaboration. I mean, uncertainty is certainly a difficult part, but I think there are many games with uncertainty, for example, poker, and there are many techniques for dealing with this uncertainty. I think that communication collaboration is still very much an open problem. Not only communication, I think just making like reasonable sentences is already a problem that is very difficult, but keeping knowledge, maintaining the knowledge in your head and doing an argument, I don't think that like having the AI make a persuasive argument, I think that's a very, very hard problem.
Yeah, that makes sense. I mean, there's a lot of things that it's like you can solve the natural language problem like on its own, or you can also have to tie it into a lot of these other sort of interesting dynamics that the werewolf makes you do.
Yes.
Okay. So actually I have a couple more questions, which is great.
Yeah, that's cool.
Yeah, very exciting. So lots of game AI used for solving practical problems like planning and contribution problems. I think the question here is, what aspects of Werewolf are aspects of problems that you would use like general AI to solve? Or like, how does Werewolf AI translate to that?
I mean, if we think that one of the key skills in Werewolf is to lie, I think Werewolf is a stepstone to have AI politicians. But okay, that was okay. So bad joke, but actually, I think that Werewolf AI is a very good point for having AI do task. I forget the term right now, but when you have natural language communication with like task-oriented language, like I was saying before, having the AI being able to make an argument for a position, or having the AI being able to understand the argument of someone else, having the AI being able to understand what you're trying, what do you want, and then negotiating with you. So this sort of like, not only like being able from the point of view of being able to understand your argument, but being able to read cues, or being able to give how do you say, body language, or being able to express some sort of emotion, so they are humans can empathize with AI and stuff like that. I mean, if you think about what are the skills of a good Mafia player, the skills of a good Mafia werewolf player is like being able to have an argument of other people, being able to lead other people, being able to understand the arguments of others, to understand what other people want. So all this sort of like making a more empathetic AI are things that have to be solved for the AIWolf game, and they are useful for many other applications.
Yep, makes sense. So last question from Luke. Have some of the previous competitors tried to model or use emotions as part of their strategy, either in NLP or robotic?
Yes, for both. So yes, in the protocol division where they used the fixed protocol, there was one very interesting player that every game they would choose a how to say, they would choose a psychological profile for the agent, and the agent would play following that psychological profile. It was something very simple. I mean, they used the big five psychological characteristics, but the final result was the agent was either aggressive or defensive or cooperative or antagonist. So they used that sort of modeling the personality of the agent. In the NLP, that's also a big part of the NLP. So they also try to, the participants in the NLP try to model the agents as like being very forward or being more timid or talking more or talking less. So trying to model the emotion of the agent is a big part of NLP, and it's a part of some agents that have been submitted. But I think there is still a lot of space to grow here.
Cool. Well, I think we're all looking forward to seeing what comes out of it. So just as another call to everybody, like if you're interested in this kind of stuff, please join the competition. I think that would be great for everybody. And yeah, so thank you for everyone who submitted your questions. I hope this has been a good talk for everybody. The next part of this event is an offline Zoom call. So that link has been posted in the YouTube chat. So feel free to click that link and join us. And besides that, thank you so much, Klaus, for your talk.
Thank you everyone for coming and watching, and thank you for inviting me, Lisa.